Hey there, tech enthusiasts! Today, we're diving into the fascinating world of computer networks by exploring the Open Systems Interconnection Model, or OSI model for short. This model is fundamental to understanding how different networking protocols interact and communicate with each other. Imagine you want to send a message to a friend across the globe. It's not just a simple click and send, there's a lot more happening behind the scenes. You type it on your phone, hit send, and boom, it magically appears on their screen. But how does this magic actually work? What happens behind the scenes is a complex process involving multiple layers of communication and data transfer. This is where the OSI model comes in. It breaks down the communication process into 7 distinct layers, each with its own specific function. It's like a blueprint with 7 distinct layers, each with a specific job, that ensures your message reaches its destination. These layers work together to handle everything from the physical transmission of data to the final delivery of the message. This layered approach simplifies networking by breaking down complex processes into manageable chunks. Each layer only needs to focus on its specific task, making the entire system more efficient and easier to troubleshoot. Think of it like a well-oiled machine, where each layer performs its role seamlessly to keep the entire system running smoothly. If one layer fails, the others can often compensate, ensuring reliable communication. Understanding the OSI model is crucial for anyone interested in networking, from casual users to seasoned professionals. It provides a common framework that helps different systems and devices communicate effectively. So, buckle up as we embark on this exciting journey through each layer of the OSI model and unravel the mysteries of computer networking. Let's get started. At the very bottom of our OSI model pyramid, we have the physical layer. It's the most fundamental layer, dealing with the physical transmission of data as bits, those magical zeros and ones, over a physical medium. This layer doesn't care about the meaning of the data, it's all about the how. Imagine plugging in an Ethernet cable or connecting to Wi-Fi. The physical layer defines the specifications for these connections, including the type of cable, connectors, voltage levels, and signaling techniques. It's like the delivery truck driver who doesn't care what's in the package, he just makes sure it gets to the right loading dock. Examples of physical layer technologies include Ethernet cables, wireless, Wi-Fi and Bluetooth, and fiber optic cables. Each of these mediums has its own unique characteristics like speed, range, and susceptibility to interference, all defined by the physical layer. Without it, our data wouldn't have a physical path to travel on. Moving up the ladder, we arrive at the data link layer, responsible for transmitting data between devices on the same network. Think of it as a local postal service, ensuring your letter reaches the correct house within your neighborhood. It takes care of error detection and correction during data transmission. This layer introduces the concept of MAC addresses, unique identifiers assigned to every network card. Remember those long, weird numbers on your router or computer? That's your MAC address. The data link layer uses these addresses to ensure data is delivered to the right recipient on the local network. One of the most common protocols at this layer is Ethernet, which defines the rules for communication on most wired networks. The data link layer packages data into frames, adding header information like source and destination MAC addresses for proper delivery. So, next time you're transferring files between computers on your home network, thank the data link layer for making it happen. Now imagine you want to send a letter to another city. You carefully write down the address, seal the envelope, and drop it in the mailbox. You need the postal service to figure out the optimal route and deliver it to the correct address. The postal workers sort the mail and the mail truck navigates through city streets to ensure your letter reaches its destination. That's exactly what the network layer does for our data packets. It ensures that each packet is sent through the best possible route. It's responsible for routing data packets across different networks, ensuring they reach their final destination. This involves complex calculations and decisions to find the most efficient path. This layer introduces the concept of IP addresses, unique identifiers assigned to devices on a network. These addresses are crucial for directing data to the right place. Unlike MAC addresses, which are permanent, IP addresses can change depending on your network connection. This flexibility allows devices to move between networks seamlessly. Think of it like your home address versus your work address. Just as you can have different addresses for different locations, devices can have different IP addresses based on their network. The network layer uses routers, special-purpose devices that act like traffic directors, to determine the most efficient path for data packets to travel. Routers analyze the network and make real-time decisions to avoid congestion and ensure smooth data flow. They use routing protocols like IP, Internet Protocol, to navigate through the vast network of interconnected networks we call the Internet. These protocols are the rules that guide data packets on their journey. Without the network layer, our data packets would be hopelessly lost, unable to find their way across the vast digital landscape. It is the unsung hero that keeps our digital world connected and functioning smoothly. Section 5. Ensuring reliable delivery. Transport layer, also known as Layer 4, is a crucial component in the OSI model. It plays a vital role in managing the delivery of data across networks. We're halfway through our journey. Just like a marathon runner needs to pace themselves, the transport layer ensures data is sent at a manageable rate. The transport layer acts as a reliable messenger service, ensuring data is delivered reliably and in order. It guarantees that the data packets arrive at their destination without errors. It's like sending a package with tracking and insurance. You want to make sure it arrives safely and intact. This layer provides the necessary mechanisms to ensure data integrity. This layer is responsible for segmenting data from the upper layers into manageable packets and reassembling them at the destination. This segmentation and reassembly process is crucial for efficient data transfer. It also handles flow control, preventing the sender from overwhelming the receiver with too much data at once. This ensures a smooth and efficient communication process. The transport layer uses two main protocols: TCP, which stands for Transmission Control Protocol, and UDP, or User Datagram Protocol. Each protocol serves different purposes and has its own unique features. TCP is like a reliable courier service, providing guaranteed delivery and error correction. It ensures that data is delivered accurately and in the correct order. It's used for applications that require data integrity, like web browsing and email. These applications need to ensure that the data they send and receive is accurate and complete. UDP, on the other hand, is like sending a postcard. It's faster and more efficient, but doesn't guarantee delivery. This makes it suitable for applications where speed is more critical than reliability. It's used for applications like video streaming and online gaming, where speed is more important than guaranteed delivery. These applications can tolerate some data loss without significant impact on performance. Section 6. Managing Conversations, Session Layer, Layer 5. Imagine having a phone conversation. You establish a connection, exchange information, and then hang up to end the session. The session layer is like the phone operator of the OSI model. It manages the establishment, coordination, and termination of connections between applications. This layer allows different applications on different computers to communicate with each other, even if they're using different operating systems or hardware. It also handles authentication and authorization, ensuring only authorized users can access specific resources. Think of video conferencing or online multiplayer games. The session layer ensures a smooth and synchronized experience for all participants by managing the connection and data flow between them. It also allows you to resume a download or upload from where you left off, even if there's a temporary interruption in the connection. Section 7. Presenting Data Presentation Layer, Layer 6. We're getting closer to the top. The presentation layer is all about making sure data is presented in a format that both the sending and receiving applications can understand. It's like a translator, ensuring everyone speaks the same language. This layer handles tasks like data encryption and decryption, ensuring sensitive information remains secure during transmission. It also converts data between different formats like ASCII and Unicode, so applications can communicate seamlessly. For example, when you view an image on a website, the presentation layer is responsible for decoding the image file format, like JPEG or PNG, and displaying it correctly on your screen. Section 8. Interfacing with Applications, Application Layer, Layer 7. Finally, we reach the top layer, the application layer. This is the layer that interacts directly with user applications like web browsers, email clients, and online games. It's the interface between you and the network. The application layer provides services like file transfer, FTP, email, SMTP, and web browsing, HTTP. It's responsible for displaying the information you request and sending your requests to the lower layers for processing. Think of it like this. You use a web browser application layer to access a website. The browser then interacts with lower layers to send your request and retrieve the website data, which is then presented to you. Section 9. The importance of the OSI model. Congratulations, you've reached the summit. We've journeyed through all 7 layers of the OSI model, from the physical transmission of bits to the applications we use daily. Understanding this model provides a common language and framework for network professionals to troubleshoot issues, design new technologies, and ensure seamless communication between devices. While the OSI model might seem like a lot to digest, remember that it's just a conceptual framework. It helps us break down complex networking processes into manageable chunks, making it easier to understand and troubleshoot issues. So, the next time you're browsing the web, sending an email, or streaming your favorite show, take a moment to appreciate the intricate dance of data packets flowing through the 7 layers of the OSI model, silently working behind the scenes to connect you to the digital world.